Good evening. Welcome to Cellular Expert webinar. Thank you for sharing your time. Thank you to gistec company for providing this opportunity. My name is Mindaugas Dailidė. I'm sales project manager at Cellular Expert company. With me is my colleague Svajūnas Vitkauskas, product development manager. And today we are going to discuss how GIS technology can be used to map telecommunications network coverage. Also, we will demonstrate new developments from Cellular Expert. So let me start with the introduction of our company. Cellular Expert started in 1993 as the department of NIT Baltic company. NIT Baltic is an SRE software distributor in Baltic region with offices in Iceland, Lithuania, Latvia, and Estonia. In 2013, Cellular Expert was spun off as a separate company with focus purely on telecommunications. We develop ArcGIS extensions for telecommunications. We customize it as requested by our customers. Also, we provide services of network planning using our software. And of course, we provide customer training and technical support. During those years, we have exported to 52 countries for more than 170 customers. Our customers are mobile operators, telecoms, internet providers, telecommunications regulatory authorities, radio, TV broadcasters, universities, and even electricity distribution or oil and gas companies which operate their own telecommunications network. Also, important part of Cellular Expert users are military and critical communications. We provide both single-seat desktop type licenses and server-based web applications for point-to-point, point-to-multipoint, point-to-area topology networks. Here is the list of the technologies that we have implemented in our software. So how telecommunications can benefit from ArcGIS? We have witnessed impressive technology evolution with each generation delivering new amazing capabilities. Second generation brought us digital voice over analog and messaging services. Third generation basically brought the internet to our phones. Fourth generation made this internet fast, and here the things became very interesting as the availability of high-speed internet on the phones made the ecosystem of various apps boom. You know, YouTube, Facebook, WhatsApp, you name it, there is an app for every application. And this made the consumption of the data to increase a lot, and it made the main product. And now 5G has arrived. So what has it brought to us? What new amazing capabilities? Of course, our internet, mobile internet will be even faster. So technical specification for 5G is 20 gigabits per second. Ericsson has recently demonstrated 4.3 gigabits per second with aggregation of 8 carriers. Maybe it's quite difficult to imagine how we could use such amazing data rate for ourselves, but such impressive data rate can be very useful in the cases where many users gather at one location, for example, in the football stadium of 50,000 people. So there everybody can get proper service with 5G. Talking about the football. So this gentleman is kicking virtual ball using virtual reality headset and 5G network equipment from Nokia at one trade show in Dubai. And to do this, he needs the network to provide him very low latency. The latency has to be less than 20 milliseconds. Otherwise the user feels dizziness in his head. And yes, 5G delivers less than 1 millisecond. Another application is remote medicine, telemedicine. So this doctor is using manipulators and 5G network technology to do remote surgery operation. He feels how his fingers get pushed back on his micro manipulators from the instruments operating remotely. In addition to very low latency, we need here also very high reliability. We surely do not want to lose the connectivity service during this important operation. Another use case is transportation. There is huge potential for 5G in transportation. It should make the traffic safer. It should decrease congestion. It should even help save fuel. So 5G would facilitate in creating self-driving cars, and those cars will be able to communicate with all the surrounding traffic participants, like other cars, bikes, pedestrians, smart traffic lights. And so the traffic will be safer, will be less accidents. Also, the traffic can be organized much more efficiently by tracking all the traffic participants. So the traffic congestion should be better. And if we would equip the parking spaces with sensors, the smart sensors, so the cars would be able to communicate with it and know about the closest free parking spot and wouldn't have to turn circles around the block. The car could go directly to that parking location and park. Outside the cities, the trucks, cargo trucks, can drive in convoys, keeping very short distance between themselves, and save fuel by using vacuum created by car going in front of it. So many benefits. Is smart cities another application? So the cities can equip all the required activities with smart sensors to monitor, of course, traffic as well, as we mentioned, but also other areas as well, so like utilities, water, electricity, gas. So they can be equipped with smart sensors, and the users wouldn't have to go and see what are the measurements. The data can be transferred directly to centralized console. Also, temperature sensors, pollution sensors can also be equipped in waste management. Every waste bin can be equipped with a sensor which would measure if the waste bin is full or not, and then the trucks who collect those waste bins only would have to drive when required, so would make the city much more efficient. Armies could benefit from 5G, starting from using it in small warehouses, in logistics, and up to mission communication and mesh networking. So we can see very different applications with very different requirements. There are some certain technology tricks which allow to achieve these parameters. Massive MIMO and beamforming is very useful. It would allow not to send the energy, not to waste the energy on sending the signal at wide area, but it would send the signal focused towards the user. And this would allow to compensate for coverage for using higher frequencies. Also, it would allow to increase the quality of the network because the neighboring cells would cause less interferences to each other. We will have more frequency spectrum because the frequency spectrum was extended in frequency range below sub 6 gigahertz, and even more at the frequency range 2, from 26 to 40 megahertz. And having more frequency spectrum, we can send more information, more data. Carrier aggregation, again, is another technique which allows to increase data rate. Flexible numerology allows to create instance services as with required settings, with required parameters for a particular service. And the network would move from electronic circuit board controlled network to software controlled network with network function virtualization, which would allow to create slices of required services, and would probably finally would allow to move from best effort network paradigm to service as required paradigm. So how can telecommunications benefit from ArcGIS? ArcGIS Enterprise Portal is famous in sharing geospatial information. It allows for many users to connect and use same data. So first of all, the physical network assets can be mapped. All the sites, backhaul fiber infrastructure, microwave links can be mapped with all the attribute information. Else, network coverage maps can be loaded from whatever software you use to generate it. It can be loaded and shared using ArcGIS. And with our most recent development, network coverage prediction can be done directly in ArcGIS Enterprise Portal. Before going to it, I would like to show you 3D coverage visualization capabilities. So in 3D, we can generate field strength or other layers for each building floor. And this allows us to better understand signal propagation and service quality at different heights. Also, 3D can sometimes be useful in planning microwave links, especially in the areas with a lot of obstacles. So as we can see here, the microwave link can be created in 3D environment and maybe shoot in between the buildings. So what is this new coverage prediction capability from us? So with it, you can generate field strength, best server, SINR data rate layers directly in ArcGIS Portal. We had requests from our customers to make it simple for non-radar engineers. Some of them wanted to do some wide area network coverage analysis to calculate coverage of a lot of sites. Some of them wanted to do some localized analysis, like some army officers wanted to be able to, in easy way, to select any desired point on the map and model the coverage and get the understanding of the signal reach. We made it using Web App Builder from Esri. It provides a lot of flexibility in creating different widgets. So some of our customers wanted to have access to one parameters, others to other parameters. So as illustrated here, we created different widgets. We made it simple to use by moving all the parameters which do not require adjustment for particular task into the templates. So the screenshots here are from our desktop software, which allows access to all those parameters. So on one hand, it makes the software very powerful. On the other hand, it requires some deeper background of engineering and knowledge of our software. And by moving prediction models, radio settings, antenna settings in the template, we enable everybody to generate coverage and use it for their further work. Behind the front-end visual part, there are processes which take care of data import, job splitting, running multiple jobs on multiple cores to increase the speed, then combining and publishing the results. The data input can be very simple. Any table format file can be used to import network data even from the other software if you use it currently. So let's switch to the software and see it in action. Here I opened a web browser. So this new web applications is server-based application. It's accessed using web browser, and we connect to the server which is in our office. So here we have some sample location in Scotland, the city of Edinburgh. These sites are not real locations of the network. We created them quite randomly for demonstration purposes. If we zoom in, we can see that we have locations of lampposts next to the streets as possible mounting posts, as possible mounting locations for 5G small cells. Here are our widgets. So to access values, legend, layer list, prediction history window to load previously performed predictions, different widgets for coverage prediction, and widget to import the network from the file. So first, let me load a prediction of a wide area to save time. So I would not do the calculation live. I will first load it from file prepared previously. I'm broadcasting from home, so currently we are connecting to our server. I have sent job request, and now I have started receiving the data. So here we have access to layers. So let's see what layers we have here. So first, field strength layer. We can see values in the legend in decibels to milliwatts. Next, the quality layer, SINR. We can see how neighboring sectors influence each other. And again, we can access values at the legend. Next, download rate layer. Again, the values in megabits per second can be accessed at the legend. And first, second, and third best server layers to illustrate from which cell the signal is the strongest in which location. So now let's move to some live predictions. I will refresh the window first. So as a first example, I would like to demonstrate the network import and then prediction procedure. I select the desired technology, 5G in this case. My network in this case will be very small to save time, consisting of one site. So it is in the form of CSV file with location information and some radio setting. I just drag and drop into the import window. And again, the calculation is not done on my laptop. I'm just submitting the job to our server, which is in our office. So it would take few seconds to upload the job, to process it, and for us to download the results. It shouldn't take very long. Okay, let's see. It looks like the job was finished. It is, and we can load the results. Okay. So in this case, we didn't load the result. We imported the file and did live prediction. Again, we can have a look at what information we can get from it. We again have field strength, SINR, download rate, best server layer. So of course, field strength provides us information about the signal level in the area. But if we switch to download rate map, and if we increase transparency a bit so we can see buildings behind it, we can start making various analysis and insights. So in this case, I created a 5G small cell on this lamppost. And so, for example, if I have some questions from potential customers in these areas who want to receive fixed wireless access at home. So for example, for this building, I can see that if I mount external antenna, receiving antenna at the front wall, I would be able to deliver to this customer around 260 megabits per second, the data rate. If I would put this equipment inside the building, I would achieve around 120 megabits per second. So another useful information. Okay, let's do another prediction. I will refresh the page once again. And this time I want to select some site, maybe this one. So this is macro site, and I want to launch, okay, 5G prediction. I select proper template. In this case, it will be macro cell. So these are the templates that contain all this radio setting information, starting from prediction model, radio equipment setting, and antenna information. For demo purposes, we have small cell and macro cell, two templates, but there is no limitation how many templates you can have. We can create as many as different type of equipment you use in your company. And let's assign a name and run the prediction. Again, we have submitted the work order to our server via internet. Actually, I could even close this window, and we got our results back quite quickly. So again, this is the coverage of our LTE macro site, field strength layer. In this case, we could go deeper and do analysis as previously. Let me go to another case. In this case, I want to do prediction of 5G small cell. So I consider mounting my small cell maybe on this lamppost. So I select it. Again, I go select required technology, proper template, small cell in this case. And run the prediction. Again, we have submitted the work order to our server. It will take a few seconds for the data to upload and then go back to us. And here we have the results of small cell, of 5G small cell network coverage. Okay, let's go to another example. I will refresh my window once again. In this case, I want to do analysis on any desired point. So previously I have selected from available points, from macro sites, small cell sites. And in this case, I consider mounting antenna inside this botanical garden. There are no available mounting sites inside it. So I use widget to select any desired point. I consider mounting my antenna on the corner of this building. So here I have opened another widget. Here I have access to antenna height and azimuth and down tilt control. So 9 meters maybe it's too much. I go for 3 meters. In this case, I use Catherine omnidirectional antenna, so I keep azimuth and down tilt at 0. If I would use directional antenna, I could steer it by entering desired values here. But in this case, I keep it at 0. I see points, and I run the calculation. I could create as many templates as required. It could be also critical communications equipment. It could be military radios. Let's say Harris model this and this with all the parameter setting. We can help you to set up the templates. And then for the user, the using it is easy. You just select the required template, the desired location, and start generating the results. Let's see. So you see that the last job is still in the process. So, okay, it has finished. And here we have our coverage. So that is all that we wanted to demonstrate for you today. This new tool, new concept, providing coverage prediction capabilities for everybody. So if there are no any further questions, so let me thank you once again for sharing your time. If you would like to get some personal presentation, so we would be happy to do this. You can get in contact with us directly using those emails, or you can go in contact with us via our partner gistec. Thank you and have a nice evening. Goodbye.